A particle of mass m and charge q is projected in space with some initial velocity. And then there is a gravitational force and electrostatic force acting on it. Then the question is, what could be the shape of trajectory of this particle? Would it be straight line, parabola, it could be any conic, or there is insufficient information? Well, how to deal with this question? First, suppose that there was no electric field. Then we all know that the path would have been a parabola. But then if there is this electric field, because of this, the particle will start to drift in this direction and it will have this kind of trajectories. What would be the shape? What could be the shape of these kind of trajectories? So we can just take, instead of thinking in terms of two forces, mg and qe, we can take the resultant force, and resultant is this one, and then figure out the net acceleration. Net acceleration will be in this direction. Okay, so now we are dealing in terms of only one acceleration and it's easier. So you could have also had three forces acting on this particle, but you could have taken the resultant of them one by one in pairs like this, and then you can figure out the net force and net acceleration. And after you have figured out the net acceleration, then you have these cases. You can have the velocity of projection obtuse angled or acute angled or anti-parallel or maybe parallel. So what would be the trajectories in these cases? Let's think about the first case. The central idea is very simple. You should take these axes in such a way that the acceleration is along one of these axes. Then your calculation will be simple. So, and then you can take the component of projection velocity on these axes. You can mark them x and y. So suppose this is theta, then this is u cos theta, u sin theta. Then you can write the x coordinate of the particle. In the x direction, the particle is in particle does not have any acceleration. So it's simple. So in x direction you have this equation of motion, and in y direction you have constant acceleration. So you have this kind of y coordinate for this particle. And then you find a relation between x and y by eliminating t, and then you get a y is a quadratic of x, right? So y is like p2x, polynomial of second degree in x. And these kind of curves in mathematics are of course parabola, and they have an axis also parallel to y-axis. So this would be the trajectory. You can feel that this particle is moving in with constant speed in this direction, and then in the y direction it will go till some point and then come back. So you superimpose these two motion and you get this motion, and you can see that the axis of this parabola is parallel to y-axis. Okay. Then you have the second case. In the second case, you see that if this is your x coordinate, just a minute, this is your x coordinate, x and y axis. So in the x direction it will go on moving like this. In the y direction it will never turn because the acceleration is in the same direction. It will go on moving like this. So if you superimpose these two motion, you will see something like this. And you might not feel that this is not a parabola, but this is a parabola because the nature of equation wouldn't have changed. It would again be a y is equal to p2x kind of equation. So the parabola is like this, and the axis is still parallel to the y-axis like this. So it's that part of this parabola. Okay, in third case, you see it's very simple. The u and a are aligned. So in the x direction you have no motion. In the y direction there will be motion. The particle will go till some point and then come back. So this will be a straight line motion. In the last case, again, it will be a straight line motion without any turning back. So the idea is, if constant forces are acting on a body and it is projected with some initial velocity, it will either follow a straight line or a parabolic path. Straight line when a and u align. U is the velocity of projection and a is the net acceleration on that particle. And in all of the cases there will be parabolic path. So let's come to this question once again. So we have these two forces acting here, and the resultant is here, and then the net acceleration is in this direction. So we are not sure about what these values are. So we don't know whether the net acceleration will align itself towards u or not, in the direction of u or not, actually in the opposite direction of u or not.
So because you see what could be the shape of the trajectory of this particle, we should go with straight line and parabola both. Thank you.